Okay, guys, you should have out a clean piece of notebook paper. Get your notes titled and dated. This is the last exponent rule before we start putting all of the exponent rules together and to where the problems have multiple rules that have to be completed. So this last rule is applying the power to a power property. Okay. The power to a power property is pretty simple. It's very, very similar to distributive property. Okay. So on these problems, you're going to have a base that is raised to an exponent, or you might have to put that exponent of 1 on there, but everything has an exponent, remember? So everything has a base and an exponent, and then on the outside is another power. That's why we call this power to a power. So how to simplify this is you're going to do this problem exactly like distributive property. But instead of having a number on the outside that you have to distribute on the inside, you're going to distribute the exponent that's on the outside to every exponent that's on the inside. So our problem is 3 squared raised to the power, 3 to the second raised to the power of 3. So you need to distribute and multiply that number on the outside. So we're going to get 3 to the second times 3, which is going to be 3 to the 6th. Because remember, this is the base, and that exponent tells us that we're going to multiply the base that many times. So what this is saying is that we have 3 squared times 3 squared times 3 squared 3 times, because that's what our exponent is. And we know that if they're being multiplied, all we would have to do is add them. Okay, but the shortcut here is just to multiply them, because when the numbers get really large, we don't want to have to write all of these out. But that's the long version of what that means. So we get 3 to the 6th power. Okay, so for this rule, you're going to multiply the exponent on the outside of the parentheses times every exponent on the inside. Now you have to make sure that you distribute it to every single exponent. Remember, if you need to pause it, go ahead and pause it to get that all written down. I'm going to go ahead and go on to the next example, though. All right, so in this problem, it doesn't matter that the base is a decimal, okay? That doesn't matter at all, okay? Because we're trying to get rid of these parentheses. That's what the power to a power rule does. It gets rid of the parentheses. And how we have to do that is we have to basically distribute the exponent on the outside times every exponent on the inside. And you have to write out your work, guys. So we have 4.1 to the second times 7. So we get 4.1 to the 14th power, because 2 times 7 is 14. Make sure, guys, when you're writing your exponent that they are, I can easily tell that that is your exponent. A lot of you are starting to not write them small enough, and then it's looking like an entirely different number, and I'm going to count it wrong. Your exponent should be the smaller number by a lot. You should easily be able to tell what's an exponent and what's the base. Okay, so same deal here. You have to multiply the exponent on the outside times every exponent on the inside. In this case, there's 2 different exponents. So they both have to be multiplied times that exponent on the outside. So we're going to take 6 to the 4th times 4, and that's being multiplied times 3 to the 7th times 4. Okay, that's going to help us get rid of our parentheses. So we get 6 to the 16th times 7 to the 12th. So it's just like distributive property, except it's using exponents instead of the whole number that's on the outside. Okay, so it does not matter where the numbers are. They can be on top of a fraction, they can be on bottom, they can be multiplied, divided. If it is inside of the parentheses, it has to get that exponent distributed to it. Okay, so the first thing I'm going to do on this problem is I'm going to add an exponent on that 3 so that I don't forget about it. Okay, and then I'm going to take this 6 on the outside and distribute it times every exponent on the inside. So I'm going to have 3, 1 times 6 over 5, 4 times 6. So I get 3 to the 6th, 5 to the 24th. So that this is my final answer. Okay, let's do a couple more before I give you your practice problems. Remember, everything gets an exponent. I would suggest that you pause it, see if you can do this on your own. See if you come up with the right answer. Alright, so the first thing I'm going to do is put an exponent of 1 on the 4 so that I don't forget to distribute that 2 to every exponent. So I get 4, 1 times 2 times 3, 8 times 2. So I get 4 to the 2nd times 3 to the 16th. All right, let's do one more. All right, so on this one, I noticed that there's 3 different bases. So that means there's going to be 3 different multiplication problems. So I have to be careful here that I apply this 3 to every single exponent. So I have 2 to the 4th times 3, 5 to the 2nd times 3, 9 to the 1st times 3. So I get 2 to the 12th, 5 to the 6th, times 9 to the 3rd. So that this is my final answer. All right, I'm going to put up 4 practice problems. Once you get those completed, you can come and get those checked off by me so that you can move on. As always, if you have any questions, make sure you're asking, because as soon as we're done with this one, we're going to start applying all 5 of the exponent rules within one problem.